Okay, hi everyone, welcome back to this video series on introductions to firewalls, Windows 98 and Windows ME. When you use the original version of Windows 98 to dial into the internet, you can't do much in the operating system to protect that connection. You essentially establish an open connection to the internet. Granted, Windows 98 doesn't have a lot of services loaded that can be misused for remote administration, either file and printer sharing. However, if your Windows 98 computer is used for local network file sharing or printer sharing, the computer can easily be misused for remote administration. The file and printer sharing network component binds to all adapters in the Windows 98 computer. This includes any dial-up adapters used to connect to the internet. External users on the internet may have access to all files on your computers. PPTP client. You can use all recent Windows versions, including Windows 95, to create a virtual private network VPN connection to another network. The tunneling protocol used is point-to-point tunneling protocol, PPTP. The support of the PPTP protocol doesn't mean that the Windows 98 or Windows ME computer suddenly acts as a firewall just because it can initiate a VPN connection. But at least the computer is able to establish a secure connection to another network, such as the company network, after it is connected to the internet. Internet connection sharing. Starting with Windows 98 SE, second edition, Microsoft added network address translation NAT functionality to Windows. Windows versions from then on can contain a network component called Internet Connection Sharing, ICS. ICS provides networked computers the capability to share a single connection to the internet. This is typically used for home networks with a few computers that share a single dial-up connection from one computer to an ISP. Note that Windows 2000 and Windows Server 2003 include both a simplified ICS functionality and a full-fledged implementation of NAT. The address translation done by ICS provides a security benefit called IP hiding. IP hiding was originally introduced to conserve the number of public IP addresses on the internet. However, ICS or NAT hides the true IP numbers on the internal network as well. This means that one public IP address obtained from the ISP can be used to allow multiple computers on the internal network access the internet, while nobody on the outside will know the internal IP addresses. Strictly speaking, ICS uses network address port translation, NAPT, but everybody simply calls it NAT, ICS installation. Before you enable ICS on your computer that's connected to the internet, be advised that many ISPs don't allow you to share that connection with multiple computers on the internal network. Although they may not be able to detect that you're using NAT technology, their usage agreement may not allow it. To install ICS on Windows 98 or Windows ME computer, you need to have two adapters in the computer: a network adapter that connects to the internal network, and either a dial-up adapter or a network adapter for use with cable internet access or DSL to connect to the internet. The same is true for the other ICS capable Windows versions. Then proceed with these steps. So 1, choose Control Panel, Add Remove Programs. 2, select Windows Setup and then select Internet Tools. 3, check the Internet Connection Sharing checkbox to start the ICS wizard. ICS should be installed only on the computer connected to the internet. All other computers on the internal network use the ICS computer as their default gateway. The ICS computer does more than just provide NAT function. ICS also has a DHCP allocator component. It acts as a mini DHCP service and provides computers on the internal network with a dynamically assigned IP address when they are configured as default DHCP clients. By default, the ICS computer uses the IP address 192.168.0.1 on its internal network adapter and offers IP addresses in the range 192.168.0.2 through 192.168.0.253 to computers on the internal network. The ISP assigns the IP address that's used on the external adapter of the ICS computer to enable computers on the internal network to resolve DNS queries such as www.dummies.com to the correct external IP address. The ICS computer acts as a DNS proxy and forwards DNS queries from the internal network to the DNS server of the ISP. The DHCP allocator will tell the internal computers to use the ICS computer for DNS queries. The IP configuration of a computer on the internal network will look like this. So DHCP enabled IP address 192.168.0.5 default subnet mask 255.255.255.0 default gateway 192.168.0.1 DNS servers 192.168.0.1 ICS and ports used. When a computer on the internal network sends an IP packet to a computer on the internet, the ICS computer substitutes its own external IP address as the source IP address and forwards the packets on its way to the internet computer. The ICS computer keeps a list of current translations on hand in order to successfully forward any response that may arrive back from the internet that is destined for a computer on the internal network. A translation entry consists of two pairings: the internal computer's IP address and ports and the internet computer's IP address and ports. Only packets that match one of the entries in the translation table are forwarded to the computer on the internal network. Packets that are sent unsolicited by computers on the internet don't have an associated entry in the translation table and therefore can't reach computers on the internal network. If a translation entry is not used for 10 minutes, ICS removes the entry automatically. ICS can dial up to the ISP automatically when a computer on the internal network wants to access the internet. If the dial-up connection is not used for 5 minutes, ICS automatically disconnects the line. Again, you have the option of creating a static port mapping in which ICS is configured to always forward incoming traffic by using a particular port, for example, port 80. Thus linking the external IP address of the ICS computer to one of the computers on the internal network. By default, ICS blocks two ports on the external adapter, TCP port 135 and UDP port 139. These ports are used for file and printer sharing requests. ICS automatically blocks those requests at the external adapter. We discussed earlier in this chapter that Windows may offer to disable the file and printer sharing component when you connect to the internet. This only applies to dial-up adapters. ICS blocks ports 135 and 139 on an external network adapter, cable internet access or DSL as well. Windows 2000. Windows 2000 is far more secure than its predecessor, Windows NT 4.0. Many enhancements and newly added technologies enable you to better protect your connection to the internet. Enhancements and new technologies in Windows 2000 that relate to internet connection security are better packet filtering capabilities. Windows 2000 can specify both incoming and outgoing packet filters based on port, source address, and destination address. More flexible NAT implementation. Windows 2000 provides highly configurable NAT implementation. This is more flexible than the ICS service in Windows 98 SE and Windows ME. Windows NT 4.0 doesn't have any NAT functionality. Support for incoming L2TP VPN protocol. Windows NT 4.0 only supports PPTP VPN protocol. Windows 2000 computers can use the more secure L2TP VPN protocol for incoming VPN tunnels. Support for IPSec encrypted traffic. Network traffic can be authenticated or encrypted without using a VPN connection. The industry standard is IPSec. Windows 2000 supports IPSec policies to configure protected network traffic to and from Windows 2000 computers. Packet filtering. Windows 2000 allows you to specify packet filters at 4 different locations. TCP/IP filtering in the network control panel console. This is a slightly changed implementation of the packet filtering that was provided by NT 4.0, input filters and output filters per network interface. These packet filters can be specified in the routing and remote access console. The allow or block filters can be specified for different ports, source addresses, and destination addresses. Input filters and output filters per remote access policy. These are essentially the same filters that can be applied per network interface, but they now apply to the active dial-in connections that are governed by a specific remote access policy. Block and permit filters in an IPsec policy. IPsec filters are typically used to define how network traffic should be encrypted, but each IPsec filter can be used to block or allow matching IP packets as well. Packet filters in network control panel. You should probably never use the TCP/IP filtering option in the network control panel console. The packet filters that can be specified here have the same limitations as the packet filters in Windows NT 4.0. They only apply to inbound traffic that is destined for the computer itself and can listen only on TCP ports, UDP ports, and IP protocols that are allowed in. They can't be used to block specific ports or protocols. Routed network traffic from one network interface to another network interface will be unaffected by these filters. In Windows 2000, Microsoft further limited the usefulness of these packet filters. Unlike in Windows NT 4.0, you can no longer specify to which network adapter the filters should apply. They will automatically apply to all external and internal adapters. The option to enable PPTP filtering is also no longer present in the network control panel console. The Windows 2000 packet filters that you can specify per network interface in the routing and remote access console are much more powerful. Packet filters per network interface. The new routing and remote access service in Windows 2000 allows you to configure separate filters per network interface. You can define filters for incoming network traffic and filters for outgoing network traffic. The filters are defined at a much lower level in the IP network stack. Thus, these filters are These filters also affect network traffic that's routed from one network interface to another network interface. You can either specify filters that describe the traffic that should be blocked, receive all, except the matching filters, or you can specify filters that describe the traffic that should be allowed in or out, drop all except the matching filters. So to define packet filters, use the following steps. 1. Click Start and then select Programs and Administrative Tools to open the Routing and Remote Access console. 2. Select the IP Routing General node to open the Properties dialog box of the network interface for which the filters should be defined. 3. Click the Input Filters button to display and define the list of packet filters for incoming traffic. When done, click the Output Filters button to examine and define the filters for outgoing traffic. Figure 13.3 shows a list of output filters. Windows 2000 packet filters are stateless. This means that you should explicitly define the needed input filters and explicitly define the related output filters for the response packets. To further restrict the packets that can enter the internal network, you may want to check the Enable Fragmentation checking box on the Properties dialog box of the network interface. This option configures the Windows 2000 computer to discard all coming fragmented IP packets at this network interface. Packet filters per remote access policy. All dialing connections to a Windows 2000 remote access server are represented by the network interface labeled internal in the routing and remote access console. However, you can't specify packet filters on this network interface in the same manner as on the other network interfaces. Instead, if you want to filter packets to travel to and from dialed-in computers, you have to create the filters in the remote access policy that is used to define the properties of the dialed-in connections. To define packet filters for remote access clients, open the Routing and Remote Access console, select the Remote Access Policies node and click the Edit Profile button on the Properties dialog box of the remote access policy for which the filters should be defined. The From Client button input filters and the To Client button output filters on the IP tab display the list of packet filters. If you use a Windows 2000 Radius server to authenticate remote access clients, you should edit the profiles of the remote access policies on the Radius server instead. So I'm going to leave here this evening for this video. If you like listening, please consider sharing and subscribing. Thank you.